Now we go into 4.5 and 4.6. These essentially are the graphs. So if you go around the circle, the sine of 0 is 0. The sine of 90 is 1. The sine of 180 is 0. The sine of 270 is -1. And the sine of 360 is also 0. These points follow essentially the unit circle. Again, remember, sine is a second number. So I start with 0, then 1, then 0, then -1, then back to 0. And that's how I'm getting this graph. 0, 1, 0, -1, and 0. And it curves around. What will happen is you spin around, again, these are radians, so 90, 180, 270, 360, pi over 2 pi, 3 pi over 2, and 2 pi. If you increase by 90, again, think of it like this. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2, 10 pi over 2, etc., etc., etc. Every time you spin around another 360, you make the same curve as you do from 0 to 360. If you go in the negative direction, you make the same curve as well. So this thing goes forever, left and right, forever and ever and ever. But essentially, the same part repeats over and over, etc. That part that repeats is the revolution around the circle. So that's 360. So the period of sine is 2 pi. And we're going to do everything in terms of radians here. So ultimately, the period is going to be 2 pi. So the period is like a cycle until it repeats. So periodic. This is called periodic. So it's a period repeating over and over and over to both sides, forever and ever. The amplitude is the size of the wave. This wave, the sinusoidal, which is what's called a sinusoidal wave. Now the wave has a high point and a low point. So in the middle is the middle. The middle is the x-axis. Highest point is 1, lowest point is -1, but still the amplitude is the absolute value. So the highest and lowest, the highest point and the lowest point, the distance is 1. So the amplitude is the size of the wave, how big the wave is. Notice that when you graph this, sine cannot go past 1 and cannot go past -1. The reason is because sine is essentially opposite over hypotenuse. The hypotenuse will always be bigger than the opposite, and at worst, it will be the same answer. So the sine can never be bigger than 1, because I would say that the opposite side of a right triangle is bigger than the hypotenuse of a right triangle, which cannot happen. The reason we're in the negative world is because when you spin around the quadrants. So it can't go below -1, and I go above +1. Now that's unless you shift it, you add something to the graph, which we'll do in a while. But for the most part, sine lives between -1 and 1. Now cosine is the same thing, except it's a slightly different graph. This one starts with 1, then 0, then -1, then 0, then 1. The reason that is because cosine is essentially the first number. So it starts at 1, then 0, then -1, then 0, then back to 1. You're just going around the unit circle. So at 0, it's 1. At 90, it's 0. At 180, it's -1. At 270, it's back to 0. And at 360, it's back to 1. Or pi over 2 pi, 3 pi over 2, 2 pi. And so the same kind of thing with sine, except it kind of looks like, if I just put my fingers on this part here, that's really the sine graph. Doesn't it kind of feel like that? It's kind of shifted, if you will. So really one of them, it's like the other one, except just shifted by 90 degrees or shifted by pi. So some books, they would stress that sine is the same thing as 90, sine of x is the same thing as cosine of pi over 2 minus x, which is fine, vice versa. But we're not going to dwell into that too much. It's not really important as much as we need to for our discussion. So our amplitude is 1, highest and lowest value, what's called the crest and the trough, if you will. But the wave size is 1 and 1. The period P is 2 pi. It's still from 0 to 360 because that's what you're spinning around a circle. So from here to here. and then this guy from here to here. I try to line it up as best I could. It's not easy, but I try to do the best I could there. So sine starts in the middle, then the highest point, then the middle, and the lowest point, then the middle. Cosine is the highest, then the middle, then the lowest, then the middle, then the highest. So if you do translations, translations are shifts. They're movements. In this case, the value here. Positive 2 means go up. Negative 2 when you add it to trig function means down. So ultimately, take this guy and go up 2. So instead of starting at 0 for the x, I'm going to start at 2. Then I'm going to go up the size of the wave 1. So like I'm taking the whole graph that would normally be down here. It would be kind of like down here, 0, 90, kind of like this. This little piece here. I just shift it all up 2 units. So 0 goes to 2. The highest point is now, I add 2 to that, would be 3. The lowest point I add 2 to that would be positive 1. So now that's where you get the lowest point 1, the highest point 3. You just draw the same graph. This one you lower it down, so it goes down to negative 2. The size of the wave is up 1, down 1. So that's how you do the shift. So up 2, down 2. You put a number in front, like 2. This number essentially cuts it in half because the period is 2 pi over that number. This will stretch it or shrink it horizontally. So this number 2 actually says you can put 2 periods where you normally would have 1 period. So it takes the period and shrinks it in half. So instead of the period going from 0 to 2 pi, like all the way over here, it would just go from 0 to pi, half. So this number cuts it in half. This number doubles it. So you're dividing by a half, which is reciprocal is 2. So if this number is less than 1, it stretches it horizontally. If this number is greater than 1, it shrinks it by that number. So this number essentially cuts it in that many parts. So if it was like a 3, you're going to cut it in 1/3, into 1/3 of the period. That's how it works. So you stretch or shrink. And then now if you multiply on the outside, now if you multiply within the x, that shrinks or stretches the period. Now, or shrinks or stretches the graph horizontally. It changes the period. Now, if you multiply the outside by a number, so in this case, it does what you normally would think. It doubles it. So this one stretches it or shrinks it. Stretches it or shrinks it vertically. So this number here, you multiply the y values by 2, which means it takes this guy, instead of where it was at 0 to where it was to 1 and negative 1, it doubles it. If it goes to 3, it goes to 3 and negative 3, 4 and negative 4. This number multiplies to it. It stretches it vertically. So instead of going up to 1 and down to negative 1, like in this little area here, instead of here, it will double it. Like if it was a 3, it would multiply by 3. It would triple it. So it would go 3 to negative 3. If it was a 4, and so on. So that number stretches it if it's bigger than 1. If it's less than 1, it shrinks it. Becomes only, instead of going up to 1 and negative 1, it goes to half. Makes it smaller. So it cuts it in half. If you take this as a 3, it takes this guy and it flips over itself. So the top half is now the bottom half because they multiply by negative. So the positive numbers become negative. The negative numbers become positive. So the bottom half jumps up, the top half jumps down. So that's your flipping. So a negative number flips it around the x-axis or reflects it. So the 3 stretches it, but the negative flips it. That's how that works. Those are your translations, your movements. And now here, what does it mean inside here? If you subtract and add, now it's weird because if you take away, you're actually going to move it to the right because the idea is what can I put in here for x that puts it back at 0? So you have to put the opposite sign to make it 0. So to offset the negative, we have to do positive. So this means instead of starting at 0, I'm going to start at pi to the right. So I'm going to move by pi. So subtraction means move to the right. Addition, by relation to subtraction, if subtraction moves to the right, then addition moves it left. So I need to put a negative 2 pi so I can make it 0, so I can cancel it. So I have to take this graph and move it negative 2 pi to the left. This one moves the graph pi units to the right. Negative 2 pi to the left. That's how, and then cosine, the graph of cosine. Highest, middle, lowest, middle, highest, highest, middle, lowest, middle, highest. And so again, I should have added this here. This hasn't gone up or down. This hasn't shrunk sideways or vertically or anything like that. So now if you put it all together, the D on the outside means up or down. If it's positive, you go up. If it's negative, you go down. This A multiplies, essentially the amplitude. This is the size of the wave. It shrinks or stretches it vertically. If this is bigger than 1, it stretches it. If it's less than 1, it shrinks it. If it's positive, it goes in the same direction. If it's negative, it flips it. Now the amplitude, because the size of the wave, is the absolute value of whatever number that is. C over B talks about what's called the phase shift. C is this number here. It moves it right or left. B kind of shrinks it. So if you're here and you move right or left and then shrink, the X and Y still gets affected. So the ratio C over B tells you the shift of the phase. Again, where does the period begin? The phase shift, C over B. The period is 2 pi over this number, which is what you divide by. And the end of the period, well, if you start at C over B and you add 2 over pi, if you start at C over B and the period is 2 pi over B, then you add them up, that's where you're going to finish. So C over B is the shift, 2 pi over B is the period, and the end of the period is C over B plus 2 pi over B. That's how this works. Cosecant. Cosecant is a reciprocal of sine. So sine, remember, was the lowest, the middle, the highest, the middle, the lowest, the middle was in here. Now here was sine. So if sine of 0 is 0, its reciprocal should be undefined. So if I may here, notice that sine is 0 at 0 and at pi and at 2 pi. Notice it's 0 at these three values. Cosecant is a reciprocal of that. So cosecant is undefined at 0, at pi, at 2 pi, everywhere where sine was 0, cosecant is undefined. In this little region here, notice that these numbers are less than 1, like 1/2, 1/3. These are small numbers less than 1. Well, if you take the reciprocal, 1/2 becomes 2 over 1. 1/3 becomes 3 over 1. 1/4 becomes 4 over 1. So this part ultimately kind of flips on itself. So this little upside down sad face becomes a happy face going up. This happy face becomes a sad face going down because you flip backwards. So cosecant just takes these little mounds and flips it on itself. So where sine lived in this little part upside down, it flips upward. Where sine lived right side up, it flips downward. So this is the flip of sine. That's how it works. So notice that cosecant is asymptote, lowest point. Or I'm sorry, asymptote, graph going up. So if you want to look at it as the highest point, I know it's weird because this is still like the lowest point of the happy face. But if you look at it as a comparison to sine, it's asymptote, highest, asymptote, lowest, asymptote. That's how cosecant works. It's the reciprocal of sine. And then 0 to 3. And again, because it's periodic, it just kind of copy pastes itself. Like a happy face and a sad face. Happy face, sad face. Then happy face, sad face. Happy face, sad face. Happy face, sad face. Happy face, sad face. And so on and so forth. Secant is the reciprocal of cosine. Now cosine starts at the highest point here, then 0, then the lowest point, then 0, then the highest point. Notice that in the second and fourth, like if you look at 5 values, 1, 2, 3, 4, 5, at the second and fourth value, cosine is 0. So you're going to have undefined. So you're going to have highest, undefined, lowest, undefined, highest. Highest, undefined, lowest, undefined highest. So this is kind of cosecant. That's kind of like secant's region right there. That little part right there. That's cosecant. I'm sorry, that's secant. So that is essentially secant and cosecant together. I think I put that pretty close, best I could. So you can see how secant and cosecant work. Secant is the second one on the bottom, and cosecant is the one on top. So cosecant on top, secant on the bottom. That's how they work. Okay? So this one, highest, half happy, asymptote, sad, sorry, half happy, asymptote, sad, asymptote, half happy. Asymptote, happy, asymptote, sad, asymptote. That's your cosecant. That's your secant. And the same thing applies essentially for the movements. So because sine and cosine are the reciprocal of cosecant and secant, respectively, they're the same as the movements of sine and cosine. So if you add, you're taking cosecant and moving up. If you take this guy, you multiply by 2. So you're taking the secant and just kind of stretching it. So if you will, if you look at this, it says go from 0, go up to 3. And then from there, the size of the wave is 2. So up 2 and down 2. So the idea is here, this is your D. This is your D plus A. This is your D minus A, if you will. Or it's not really an amplitude, but it's kind of like you take this guy, and so all this in between is, all of this is where cosine would be. But because we're not in the world of cosine anymore, this is what you're dealing with. Okay, so as you do this, you say, okay, how does secant work? Well, actually, the secant is the same here. So secant does what? Starts at the half of the happy face at the highest point. And the next point over is the asymptote. The next point over is asymptote. Then the next one over is the lowest point, going down. Then followed by an asymptote, then the other half of the happy face at the highest point. So, again, if you want, this is your highest point, this is the middle, and this is the lowest point. So how does secant work? Highest point is half happy, then the next point is asymptote, then the next point is your lowest, then the next point is the asymptote, the next point is the other half of the happy face. And that's how it works. Except the A value is not really amplitude. It's amplitude when you're dealing with sine and cosine. So if we're dealing with sine and cosine, then in here, that is essentially the size of your wave, but it's kind of like all of the opposite part. So sine, cosine would live here, but now I'm on the opposite end. So that's why I'm doing secant that way. And the same thing with cosecant here. The displacement is -1, so we're going down 1. Here's your displacement. They're not really your amplitude, but from there you're going to go up 2 and down 2. So that's where you have the space. Okay? But now you look at your B value. B is 1. Your C is pi. So your phase shift is pi. Your period is 2 pi over 1, or just 2 pi. So the shift starts at pi, and then you're going to go 4 more spots, and you're going to end at 3 pi. Well, if you're at pi and at 3 pi, then if you're jumping by 4, you're going to actually jump, every 2 is pi. So 2 of them is pi, then 3 pi. So you're jumping by half a pi every time. So if this is full pi, is 1.5 pi, 2 pi, 2.5 pi, and then 3 pi. So how does cosecant work? Cosecant works. Asymptote is the first, asymptote the third, and asymptote the fifth. The second one is at the highest point. It's happy face. And the fourth one is the lowest point, sad face. So here's your happy followed by your sad. So as it were, how does cosecant work? asymptote, highest, asymptote, lowest, asymptote, asymptote, highest, asymptote, lowest, asymptote. And that's how you graph secant and cosecant. Now, tangent and cotangent are very similar. And sorry for all these big dots here, kind of make a mess with the pen here, but the way it works is tangent of 45 is 1, tangent of negative 45 is negative 1, tangent of 0 is 0, so it kind of curves in this fashion. But remember at 90 was undefined, so it goes up this way and doesn't touch the asymptote. So the asymptotes here are at 90s. So from negative 90 to 90, it's an asymptote. From 90 to 270, it's an asymptote. From 270 to 360 is an asymptote. From negative 90 to 90, is an asymptote. 90 to 270 is an asymptote. 270 essentially to 450 is an asymptote. So the distance is 180 or pi. The period is pi, so it kind of looks like a cubic. So it's kind of like this number. Kind of does this mess. Kind of goes like that. That's kind of how tangent works. But it repeats itself over and over and over. So it has a period. So there's no amplitude here. Now cotangent at pi over 4, cotangent is 1. At 135, it's negative 1. The problem is cotangent, because it's cosine over sine. Sine is undefined. Sine is 0 at 0 and at 180. So cotangent is undefined. It goes downward. That's your cotangent. And your period is 180. So tangent this is tangent, and this is kind of like cotangent. It almost looks like they're flips of each other vertically. So it's almost like it's pretty much like it's flipped and then kind of shifted over, but that's kind of how they work. Okay, so I just want to point that out there. Get used to these graphs, kind of study them, practice them, and then ultimately we're not gonna go up and down on this. We're just gonna multiply here. So we're gonna multiply, kind of stretch it vertically or thin it out vertically. Then the bx minus c, we're gonna shift it both directions. So if we shift it here, and again, the period is pi over b. The phase shift is c over b, and then the end of the period, pi over b plus c over b. I'm sorry, that's not right. I'll show you what I mean in a minute. The phase shift is a little bit different because you're going to go left. But ultimately, this is still the phase shift. Forget the period here. The phase shift, you're still moving to the right or left. So this is going to move to the right. So your c is still pi over 2 units to the right. So as it were here, tangent begins at negative pi over 2. If you add positive pi over 2, it's at 0 now. And that's the shift. So it'll start at 90, and it'll start at 0, and it'll end at 180. So instead of going from negative 90 to positive 90, it's going to go from 0 to pi. It's going to add pi over 2 units to the right. Your a is 2, so instead of going up to 1 and down to negative 1, you're going to magnify. You're going to multiply by 2. So notice that you're going to go up to 2 and down to negative 2. So it's going to magnify it. So your lowest point now is negative 2. Your highest point is positive 2, and your middle point is still 0. The y value is still 0 in the middle point here. So you're still going to say the same. That's how this works. Cotangent starts from the highest and goes down. Because you're not going left or right, you're going to stay in the same. So 0 to pi over 2 is where it's going to, 0 to pi over 2 is essentially where you're going to, 0 to pi is where you normally go. But this is going to cut the period in half. So it's going to go from 0 to pi over 2, which means this will be 1/4 of 1/2. So pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8. This thing's going to magnify to 3 and negative 3. That's how it goes. Essentially the highest, the middle, and the lowest. So cotangent does this. Cotangent is kind of asymptote, quote unquote highest, middle, lowest, asymptote. Tangent is quote unquote asymptote, lowest, middle, highest asymptote. And that's how this works. And that's essentially a look at how you would graph all 6 trig functions.